Okay, so this is our beginning of discussing the basics of C++. If you're following along in the textbook, this is going to be chapter 2. And again, we cover a lot of material here. What I would focus on is how you're actually going to use this rather than all the details that go behind it. But we'll cover what you need to know to get started with C++ basics in this in the next couple of lectures. So the first thing that we can talk about are comments, and these are things that you can put in a program, and these are for the person who is looking at the actual program code rather than the computer itself. The computer doesn't do anything with them. The compiler, when it translates this into object code, it doesn't do anything with the comments. So from the compiler standpoint, it doesn't matter whether they're there or not. But from the reader standpoint, it definitely matters whether they're there. And you should use comments to explain the structure of your code and how you're performing particular algorithms, describing your variables, what your thought process was when you created the program. And it's good because sometimes you don't go back and look at your code for many, many years. And it's helpful to, when you're going back to look at it, or if you're looking at somebody else's code, to have them explain how they did something. So there are two types. There is the single line comments, which are the two slashes, or you can do a multiple line by enclosing everything in between a slash star and a star slash. And so that will allow you to include multiple lines. And integrated development environments can help with both of these types of comments. The other thing to be aware of are special symbols, and these are tokens, and we'll get to these in compiler theory a little bit later on in the programming languages course that you'll take as part of your studies here. So the token is the smallest individual unit of a program written in any language, and these include special symbols, word symbols, and identifiers. So some of the special symbols that you might see are the arithmetic operators that you see in the top line. Addition, subtraction, multiplication, and division. There's the member access operator, which is the dot operator, the semicolon that terminates statements. The question mark is the ternary operator. A comma is also a special symbol. Less than or equal to, not equal to, and greater than or equal to in the bottom line. These are all special symbols and are treated as tokens. The other thing is reserved words. You'll see these, and oftentimes they are highlighted in different color depending on your integrated development environment. And these are ones that cannot be redefined. Basically, you have to keep them as they are. And they can't be used for anything other than what their intended use is. So some examples of keywords, and this is far from a comprehensive list in C++, int, float, double, char, const, void, and return. The first four of those are data types. The next one is constant. Void is a return type, and return is a statement that will send a value back from a function. So identifiers are the name of something that appears in a program, and these typically are for variables. They need to consist of letters, digits, and the underscore character, and they need to begin with a letter or underscore. C++ is case sensitive. So the example here, all capital number is not the same as all lowercase number. Again, that's, some languages are case insensitive. Some of the older ones, don't distinguish between those two, but C++ definitely does. So if you're, capitalizing the first letter of each of your variables, you want to make sure you're consistent about that, or, just use all lowercase. There are also two predefined identifiers, cout and cin, which are used for output and input. And predefined identifiers, you can redefine them, but it's not really a good idea. So, what makes a legal identifier? Basically, it needs to start with an underscore or a letter. You can't start it with a number. You can't have spaces in there. You can't have special characters like an exclamation mark or a plus, operators. And you can't start them with a digit because it would be difficult for the compiler to distinguish between an identifier and a number or a literal at that point. So some examples of legal identifiers: first, conversion, pay rate, And then some of the illegal identifiers that they give examples of in the textbook are employee salary, and that's because there's a space in between employee and salary. Hello exclamation mark. Again, the exclamation mark there is illegal. The 1+2, the plus symbol can't be used inside the identifier because that's an operator. And then second, basically you can't start things with a digit. So they give you examples of illegal identifiers, the reason and that they're illegal, and a correct version of that identifier. The other thing to be cognizant of when creating your program is white space, and basically these are the blank spaces, tabs, and new line characters or extra blank lines. And basically these allow us to separate the special symbols, reserved words, and the identifiers. And having good white space is really important. You can use it to make the program more readable. Now, there are things like the International Obfuscated C Programming Contest that where they attempt to make the programs far less readable by getting rid of white space or making the white space form different shapes for the program. You probably don't want to do that when you're starting out in the CS1 class, but you'll want to have good indentation and good white space so that it's meaningful and makes it easier for somebody else to read it. Again, a lot of times when we write the code, we think, it's for me, but if you go down the line, somebody else has to deal with that code eventually, and particularly in a professional context. And you'll want to make somebody's life easier. Somebody may be you in the future. Data types, these are the types that data can take on, or the value along with the set of allowed operations for a particular piece of data, and they fall into three categories. There's simple, structured, and pointers. We're going to get to structured at the end of 150, and pointers we'll get to in 151. So let's take a look at these simple data types, and there are three major categories of these. One is integral. These are integers, and these can be things like short, which is a short integer, long, which is long integer, bool, which is Boolean, takes on a value of true or false, unsigned character, unsigned short, unsigned int, and unsigned long. And basically, there are different values they can take on. The second category is floating point, which are your decimal numbers. These can be things like float, double, and long double. And then there can be enumerated types, which are user-defined data types. And each one takes up a different amount of space. So, you may eventually want to become cognizant of that if you're doing something like an embedded system, or, thinking about what range of values a particular variable or a particular aspect of your program can take on. But for now, the ones that you probably want to focus on are int, double, and probably character and bool for right now. So integers, again, these are the integer numbers. Some examples are -6728, 0, 78, +763. You don't need the plus sign there. It assumes it's positive unless you have a negative. 42 would be another integer value, and you can't add commas in there, even though that's something we commonly do semantically within the English language. Is we write 32,378 for 32,378. You would only use commas if you were separating items in a list. So, you just write that as 32378, no comma included in there. The Boolean data type, or bool type, it takes on two values, true or false, and these are used to manipulate Boolean expressions for those conditional things. If a value is greater than 7, that would be a Boolean expression, and it could either be true or false. And true or false are logical values that you can assign to bool. And bool, true, and false are all reserved words, so you can't really change their meaning within the context of the program. Character takes on single characters for letters, digits, and special symbols, and they're enclosed in single quotation marks. A blank space is also a character, and you write it as the apostrophe space apostrophe with the space left in between those single quotes. Or I guess that should be single quote rather than apostrophe, but in reality, they're the same thing. And there are different character sets. Probably the one that's most common that we'll be using for our programs in CS1 here is the ASCII, the American Standard Code for Information Interchange. And there are about 128 different values that can be taken on. And the characters have a predefined ordering based on their ASCII numeric value. And there's a table in one of the appendices in the textbook if you want to see what those are, or you can do a simple Google search. Floating point data types, these are used for real numbers or decimal values. Float uses 4 bytes, so there's less precision with it, whereas double represents any real number in the range from minus 1.7 times 10 to the 308th to 1.7 times 10 to the 308th. And there are some limitations there. We'll get into some of those limitations when you take the numerical analysis class. But for now, assume that it can represent those real values. And the minimum and maximum values of these data types are system dependent. So these are the values given in Malik, but your mileage may vary depending on what system you're programming. Finally, strings are not really a basic data type, but we're going to start out by treating them as a basic data type. It's programmer defined type supplied in the standard C++ library. And string is 0 or more characters enclosed in double quotation marks. For example, the name William Jacob that you see in the quotes down there could be assigned to a string. And you also have null or empty strings with no characters, and strings also have relative positions. And it's C++, so everything starts at position 0. So the position of the first character is 0. In the case of William Jacob, that would be the capital W. And length of the string is the number of characters in it. And we'll play around with including some strings in our early programs in this class. So to declare a variable is something that holds a value in a program. To declare them, you need a data type and an identifier. For example, int counter. Counter would be the variable and int is the data type. So counter could hold any integer value. Interest rate is a double, and so that could hold a decimal value. And grade is a character, so it can hold a single character. So when we want to put a value into a variable, we use the assignment statement, which is the equal sign. So here we can say interest rate is equal to 0.05. And again, when C++, we terminate that statement with a semicolon. So when we have our variables and values, we can do arithmetic expressions. And the basic arithmetic operators include addition, subtraction, multiplication, division, and the percent, which is the modulus. That's the remainder. And you probably remember that if you did long division in elementary school. For example, 7 goes into 45 6 times with a remainder of 3. So 45% 7 would be 3. It would give you the remainder. And they can also be used with integral and floating point data types, but the modulus can only be used with integral data types, with integers. And integer division is something different because if both values are integers, then it will give you back an integer. So that 45/7 would give you 6, and then you would get the 3 by doing 45% 7. So you would get the 3. If you wanted to get it as a decimal value, you would have to have both sides of that as decimal. So 45.0 divided by 7.0. That would give you the decimal value. And order of operations pretty much works as you would expect. The parens have the highest priority. Multiplication, division, and modulus are the next level of precedence. Addition and subtraction are the same level of precedence, are evaluated last. And then we perform operations from left to right in terms of associativity. One thing to be aware of is mixed mode. If the operator has the same type of operands, it's going to behave fairly Well, if it has both types of operands, for example, 45 divided by 7.0, the integer gets changed to a floating point. And that's called a coercion. The operator gets evaluated and the result will be in floating point. So you can have things that are changed from one data type to another, and that's called coercion, and something you may want to be aware of if you're doing scientific calculations, and we'll get into a little bit of that in the numerical analysis course. And so there's implicit type coercion when the value of one type is automatically changed to another, like the example that I had on the last slide. There's also explicit, where you explicitly say, hey, I want to change that from one type to another. And that's the cast operator. So in C++, you would do static cast. You would give the data type. So for example, static cast double. 3 would change 3 to 3.000, etc. So that takes that 3 and changes it from an integer to a double precision data type. And that's it for the first part of our discussion on C++ basics. Thanks for following along with me today.